We're gonna be doing more Greenbook. I'm just on here because the text in the probability section talked about the methods used in this one, so I'm just looking at this. But yeah, I'm gonna be doing some probability problems now. I haven't completed the brain teasers, but I don't. I just want to get to the probability stuff. I'll revisit whenever I feel like it. But yeah. But yeah, I'm just looking at these things like because they mentioned the techniques used in chapter 2. So that's problem simplification. Um, okay, logic reasoning is whatever. I think I already know these techniques, but just in case there's something that I don't use normally. Okay, thinking outside the box. Okay. Um, yeah, application of symmetry. Yeah. Okay, series summation. I mean, yeah, that's standard stuff. Pigeonhole. I don't know, modular arithmetic. I'm pretty bad at that. Math induction. I mean, proof by contra. I mean, I don't need proofs and shit. So, all right. I think that's about it. And I don't know why. Maybe this is useful on the job or something. But like, yeah, I'm gonna just jump straight into this. So yeah, I mean, I already read the part up top. You can pause if you want to read it. Um, but yeah. Mm, okay. Oh, my bad. I was just getting something in my bag. Alright. Mm, okay. Not much to see there. Probability of an outcome. Yeah. I mean, I think I know all of this stuff, but I'm just reading it because why not? Okay. I'm not reading all that. Probably fine. Oh. Alright, hold on. Alright. We'll start with the first problem. I should probably time myself, um, but like, I don't know. I'm gonna see. Um, trying. I'm not gonna be reading the solution. It's gonna be on the screen though. But yeah, okay. Two gamblers are playing a coin toss game. Gambler A has n plus one fair coins. B has n fair coins. What is the probability that A will have more heads than B if both flip all their coins? Mm, so okay. Um, so it's the probability that like okay. So let's say I only consider n of the coins, and I compare it with B's n, and then I just find probability that it's a greater than or equal to amount, and the next flip of A will guarantee that. Um, so probability that like okay, so ignore the n plus one. Say they both have n coins. I'm gonna be doing all this in my book. So yeah, but assume they both have n coins. Probability that they have the same um, the same number of heads is like okay, I'm assuming it's not like I'm assuming it's not like you need to care about the order or something. So yeah, okay. Probability. So probability that 0 coins is probability of anything happening is straight up just 1/2 to the power of n. So the probability that they have an equal number of coins or like equal number of heads is n times 1/2 to the power of n. Um, and in that case, the the flip of a should be times 1/2. So that constitutes to that, and then like the next one is 1 minus whatever this probability is over 2. So I don't know if I need to simplify it. Um, is this? Oh yeah, they do cancel out. Okay, interesting. Yeah, it does come out to be 1/2. So and this sounds like cap, but I can like say my equation out. So this is I had n times 1/2 to the power of n plus 1 plus 1/2 minus 1/2 to the power of n plus 1 times n. So the n times 1/2 to the power of n plus 1 cancels out. My my instinct was anyways to say 1/2. The only reason why I wanted to calculate it out is because of the probability that they have like an equal number of heads. That I thought that would have like made it maybe more likely or something. But yeah, I think yeah, I think that doesn't make any difference. So okay, that one was pretty simple. Let me see if okay, is this the end of the question or okay, yeah, it is. Okay. Okay. I like how they had to say Jack, Queen, King there. A casino offers a simple card game. There are 52 cards. Okay. Each time the cards are thoroughly shuffled. So each okay, yeah. Um, you pick up a card from the deck, and the dealer picks another one without a replacement. If you have a larger number, you win. If the numbers are equal, or yours is smaller, okay, the house win. As in all other casinos, the house has better odds of winning. Okay. What is your probability of winning? Okay. Mm, so if I can just do 1 minus the case where, like, 1 minus the case where we pick the same card, so would that be 6/13? Because, actually, wait, no. The probability that we pick the same card is, so let's say I pick any card, you have to pick 3 out of 51, so 1 out of 17. So that would be 8/17 of winning, I think. 8/17. Yep. Okay. Nice. Drunk passenger. A line of 100 airline passengers are waiting to board a plane. They each hold a ticket to one of the 100 seats on the flight. For convenience, let's say that the nth passenger in line has a ticket for seat number n. Okay. Being drunk, the first person in line picks a random seat. All of the other passengers are sober and will go to their proper seats unless it is okay. Okay, unless it is already occupied. In that case, they will randomly choose a free seat. Your person number 100. What is the probability that you end up in your seat? All right, how the hell am I supposed to do this? So the probability, okay, let's say the probability that the drunk guy picks the right seat would be 1 out of 100. In that case, you do make it to your seat, right? But let's say he, like usual, would probably mess it up. Let's say 99 or 100. Let's say he took number 5 spot. Um, Now, 5 will also always take up someone else's spot. And that will keep on going until 99 has to find their spot. They're like, hey, I have no other spot. Will I think that just I think it's just 1 out of 100. I don't think because is there any way where they get back their original seating and then you also do get back your original seating? Like, let's say one takes like the nth. Let's say one takes the nth person spot. Now 2 to n minus 1 is all perfectly fine, and n is also taken. Oh, I guess um and n is also taken by 1, right? Now then n has the choice to pick from like whatever. So the best case scenario is that if like they happen to swap and then like it's all good from there. So okay, so 1 out of 100 plus in the 99 out of 100 case, uh, whoever that n is has to pick number 1. So and but the thing is it's random, right? Uh, is that the only way? I guess there can be like so many more swaps that happen after that, right? Because let's say 1 takes 2's spot, right? And 2 takes 3 spot, and 3 takes 1 spot, right? That's like self-contained, but they all just took the random. So there's gonna be way too many cases, and I've noticed that the previous ones are like symmetry type ones. So I'm trying to see if there's anything like symmetrical. I'm gonna look at the hint 3. If you're trying to use a complicated, yeah, go back and think again. Yeah. Okay, symmetry. So okay, induction or symmetry. Interesting. Okay. Hmm. You know what? Let's do induction to see like what's going on, so we can just get our answer. But I want to get it intuitively, so I'm not gonna do induction. I think induction might just reveal the answer a little too easily. Um, okay, symmetry. Interesting. Yeah, I had a feeling that would be the thing. So there's a. Because in the case, so 100th of the case, it's like you are making it. But let's look at the 99 out of 100th case. You are you basically subject to like random picks? Interesting. I'm not sure. What is the probability that you end up in your seat? Is it like you think of it front to back and back to front or something? Because that's the only way I see symmetry. Symmetry in like order. That's the only way. Or like 99 people are. Is it 1 over 99 or something? Because like the first guy picks randomly. And. Mm, I don't know. Let me see. Bro, 0.5? That high? Holy shit. Okay, let me see. Consider the seats 1 and 100. There are two possible outcomes. Seat 1 is taken before 100. Okay. Seat 100 is taken before 1. If any passenger takes seat 100 before 1, surely, yeah. But if any passenger takes 1 before 100 is taken, you will definitely end up in your own seat. Isn't that the same thing for like all seats basically? Like, before 100 is taken, you definitely end up in your own seat. Is that true? If any passenger takes 1 before 100, you'll end up in your own seat? Why is that? Oh, okay, because like the torture ends there, you know? So like, oh, okay, like by torture I mean like past like being annoying to the next guy, cause like, oh, that's so, oh, that's insane. Okay, cause like one takes number 7, let's say. Like if 7 were to take like 30 or something, now the burden is on 30 now because 7's already seated. So now 30 has to take, like, let's say it takes 25, right? It keeps on going, but the cycle ends when you the cycle ends when you pick one because the burden's like already done. So now everyone gets to fill it up. So all seats from like between 2 and 99 like, and there's two seats 1 and 100 that are like competing. So either one's taken or you're taken. Oh, okay, that's crazy. Okay. Oh, okay. This one I spent like the like I think 2 videos ago. I think this one's 3/4. Uh, like, right. What is it? Okay, but I'll see these guys' solution. I'll try to derive it again. So let me do it again actually. So circle. Now there's one. Let's say I fix a point. The way I did it was like the second point can be genuinely anywhere, but like there's like a probability distribution for the position of the point. So if the point is like like exactly vertically across, um, or like slightly vertical. So if it's exactly vertical, okay. If the point lies exactly on the other point, then the third point can be like genuinely anywhere, and you can create one. So like there the probability is 1, and then when you move like almost diametrically away from it, uh hold up, so let me see. So it's either this or it's that, right? So but like let's say it's like really close, like that. So that can be it, or that, yeah, then it gets closer to like just 1/2 pretty much. So um yeah, so it goes from 1 to 1/2 with like equal probability, so it's 3/4. Um, but yeah, I want to see how this guy solved it because yeah. Okay, let's start at 1 point and clockwise label the points as 1, 2, n. Okay. The probability that all remaining n minus 1 points from 2 to n are in the clockwise semicircle starting at point 1. Um, but why would the semicircle have to start from point 1? Can it not be? Is 12 o'clock? Are all between, yeah. Similarly, the probability that the clock at I, okay. Oh, okay, okay. Is exactly in that region is Oh, okay, I see. So one, two, so it's oh interesting. So it's I over two to the n minus one or something, or sorry, n over two to the n minus one. Hold on, but let me truly wrap my head around this. Like I get it, but my only problem though is like let's start at one point and clockwise label. Oh wait, never mind. Okay, that does work. Because I was thinking like, what if like let's say if you look at my mouse here, like let's say a point is over here, let's say where a passenger is, and I was thinking like let's say this is the big circle here. What happens if the next point is here? Like, what's the point of checking this semicircle that's already passed? But that doesn't matter because this like that's not the only case, right? Because this point can be like down here or like to the left, and in that case, that would cover the thing, even though it's the last one. So that is cool. Mm, that is interesting. But are they mutually exclusive? Like, because I think as soon as you shift by one, that one you just shifted from is not no longer going to be there. So I think it is mutually exclusive. I just thought of that because like I saw it in the hint on the bottom. Like, are these events mutually exclusive? Um, yeah. If we start at any other point in order to, so we cannot reach all points within a clockwise semicircle starting from any other points. Yeah, because it just gets rid of the point right before. So yeah, does not make sense to. Yeah, because yeah, I mean that's pretty trivial to prove. So hmm, if the ratio of the arc length to the circumference, but wait, let me see here. Wait, my proof is that like my proof for why it's mutually exclusive is kind of cooked. Like I think I can justify it, but like it's pretty janky. But let's see what he says. Wait, what conclusion? Hold on. Let me. The claim is that they're mutually exclusive. Okay, if we start at point I and proceed, yeah, then any other point at starting at point J, we cannot encounter all. Okay. If starting at point I and proceeding clockwise along the circle, we sequentially encounter I plus 1 to I minus 1 within half a circle, the clockwise arc between I minus 1 and I must be no less than half a circle. If we start at any other point, in order to reach all other points clockwise, the clockwise arc between I minus 1 and I are always included. What? So we cannot reach the clockwise arc between I minus 1 and I is always going to be greater than, oh yeah, it's always going to be greater than pi. So if I shift it by any amount, and I need to include I minus 1 and I, it has to be greater than pi. Oh yeah, that's a really neat uh, proof. But yeah, okay, cool. Uh, okay. Number of different ways that a certain event can occur. Okay, yeah, fair. Um, yeah, where the order matters. So like, Yeah, fair. The order doesn't matter, so distinct. Oh, okay. Okay. I mean, okay, the only reason why I'm spending time here is because I'm just looking at the definitions. I never liked the definitions. I always like I don't usually get what order matters, order doesn't matter. Like I say it, but like when I actually do a problem, I get confused as to what I'm actually saying. I'm just trying to think of it. So like how many ways to arrange like a b is like 4 factorial over 2 factorial times 2 factorial. Why am I saying order doesn't matter? Because order between the a's and between the b's, right? Um, but if I were to say a1 a2 over b1 b2, no, that's not even the explanation. Oh wait, no, that is permutations though. In that case, why is okay? I guess maybe it's the way I'm phrasing the what I'm doing. Yeah. Okay. Well, whatever. Okay. Okay. So poker is a card game in which each player gets a hand of 5 cards. There are 52 cards in a deck. Each, yeah, I don't know why I'm reading this, but yeah, I know what poker is. Uh, oh wait, I thought this was a problem. Okay. Okay, what are the oh wait, no, this is a problem. Whoops. Okay. What are the probabilities of getting hands with 4 of a kind, hands with a full house? Okay, so 4 of a kind is um, so there's 13 choose 4 ways of picking the 4 of a kind, and then for your fifth one, it's like any of the remaining, so 48 choices for the fifth thing. Over 52 choose 4, right? So like, so not 13 choose 4, 13 choices. Um, so oh yeah, wait. So there's 13. So 13 times 48 over 52 choose 4. That's 1. Um, hands with a full house, so 3 cards of one value, 2 cards of another value. Okay, so there's 13 ways to pick the first one, or the one with 3 cards of one value. And then there's 12 ways to pick the one with the second one, and then times 4 choose 3 times 4 choose 2 over 52 choose 4. And then hands with 2 pairs. So they have to be this. So 13 choose 2 ways to pick what the 2 pairs are. And then 4 choose 2 squared, I'm assuming. So 4 choose 2 times 4 choose 2. And then the remaining one can just be, it can't be from those two things. So I only have 11 times 4, so 44. And over 52 choose 4. So numerator wise, it's like 13 times 48. Then there's 13 times 12 times 4 choose 3 times 4 choose 2. Then there's 13 choose 2 times 4 choose 2 squared times 44. So yeah, I think that's what I said, right? Yeah. And yeah. Okay. Cool. And okay, cool. Whoops. I just gotta keep checking, like, if the problems are still up there or here. Okay. Hopping rabbit. Um. Is this like a Fibonacci series? So like, how many different ways? Like, so this is like, 1 plus phi to the power of n over 1 minus phi to the power of n, I think, right? Like something like that. Phi is 1 plus square root of 5 over 2. I think unless I'm just going insane, so we'll see which one it is. So I think it's, what's the Fibonacci? You know what? Actually, this is a good time to try and derive it. So Fibonacci is like fn equals fn minus 1 plus fn minus 2, and then you assume the solution to be um, like r squared, right? Um, right? I think you assume the solution to be of the form of a times n squared, um, or a times r to the n. Sorry. I don't know if you do a plus c or something. I think you just assume a times r to the n. So I'll just do that. So a times r n equals a r n minus 1 plus a r. Okay, so I think it's just r squared minus r plus 1 is 0. So 1 plus or minus square root of b squared 1. Sorry, r squared minus 1. So yeah, over 2. So 1 plus square root of 5 over 2 to the power of n. Oh, I think it's just, uh, 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 right? I don't know if my thing just just messed up my recording, but yeah, okay. That's 1 plus 5 to the power of n, but like, let's say, okay, let's say like f of 1 is equal to, it's just 1, right? So what would make this 1? I think square root of 5 minus 1 over 2. So I think, but then that would always just be 2 to the n, I think. I don't think that's the, I'm probably not doing this right. So like, I don't know. I do think it's like solving that formula or whatever. Yeah, yeah. I mean, this is just a DP thing, but I thought they would have to. You know what? Let me actually search up the formula. On my phone. Hold up. Fibonacci. Oh wait, I think it is what I was saying. Hold on. Oh, but I was just missing like some bullshit. Okay. So it's phi to the n minus the conjugate of it. So 1 plus square root of 5 over 2 to the power of n minus 1 minus square root of 5 over 2 to the power of n over square root of 5. I mean, sure. Okay. I will look into the proof and stuff. I'm pretty buns at like recursion and stuff. I know that's kind of useful in random blocks, so I guess that's a problem for another day. So yeah, okay. Uh, Having peacefully divided the loot, the pirate team go on. Okay, and expands the group to 11 pirates. Okay, to protect their hard-won treasure, they gather together to put all the loot in the safe. Still being a democratic bunch, they decide that only any majority of them, more than six, at least six, okay, can open the safe. So they ask a locksmith to put a certain number of locks on the safe. To access the treasure, every lock needs to be opened. Each lock can have multiple keys, but each key only opens one lock. The locksmith can give more than one key to each pirate. What is the smallest number of locks needed? And how many keys must each pirate carry? Okay, I didn't even get part one, so I don't know how I'm gonna get part two. But okay, but I am gonna think about it. So let's see. I think I just have a mental block for this problem because I don't feel like solving it. To access the treasure, every lock needs to be opened. Okay, and you need any majority of them. Okay. Each lock. Okay, I think for smallest number of locks needed, I think I have to look at the case where like only six, like exactly six can open the safe, and then like anything more, it's like whatever. Let me see if I can do it for only six of them can open. If only six of them can open the safe, I don't know if that's harder. Each lock can have multiple keys, okay, but each key only opens one lock. Okay, so I think for any six of the 11, so out of 11 choose six. How many ever ways that is? I think that's even calculable. I don't know. Oh, that's not a word. Calculatable. That's calculable. I don't know. I don't know. 11 to 6 ways to pick your group. And then every single one of them needs to have it. Is this like pigeonhole or something where minimum number of locks needed? I mean, wouldn't that just be 6? Am I tripping? Like, I mean, what if I just have one lock? Oh wait, like, oh, I'm stupid. Yeah, I mean 6 locks, but like, hold on. Actually, if I have like 5. Oh, only a majority can open them. Yeah, so I must need 6 locks, and I don't know. I thought it was. Okay, let me see this. Let's randomly select 5 pirates from the 11-member group. There must be a lock that none of them have the key to. Oh, yeah, that's a good way to think about it. Okay, so then, okay, now given that information, how do I convert it? So 11 choose 5. There must be a lock that they can't. Okay, I don't know. Okay, yet any of the other 6 pirates must have the key to this lock. Okay, since any 6, yeah, okay. In other words, we must have a special lock to which none of the 5 selected pirates have the key, and that 6 pirates all have the key. So for each combination of 5 pirates, there must be a special lock that they just can't open. The minimum, yeah. Yeah, and the six other pirates all have to have the key for it because if they were to join, it should have it. Okay. So the minimum number of locks needed is so like in general you need 462 locks, and each person should have like okay, which are given to a unique six-member. Each lock has 6 keys. The minimum number of locks needed is that much. Oh, because okay. Oh, wait. I get that. Okay. So each pirate must have times 6 over 11. Why is it times 6 over 11? I'm stupid. Hold on. So there's 462 locks. Oh, because each pirate is going to be in 6/11th of these locks, or like of these groups, right? Yeah, okay, interesting. Uh, whatever this is looks interesting. I don't know what that is. Chess tournament. Oh my god, I don't wanna. Oh, I don't wanna read this. This looks like a pain. I really wanna cut it here. What time is it? It's 11. I mean, it just keeps going on and on. I might do like a few interesting problems. This one's way too long. I'll spin back on this. Application letters, that also seems like a pain. I do want to do, this one does seem interesting though. What's it called? Oh, I actually remember this. Like I remember doing this problem. Uh, but I didn't like how it was concluded because even though I found the like mathematical, like even though I found like the way to write it in a better way, I think like I didn't like the way it was done. I think so. Like I remember like 1 plus square root of 2, square root of 2 to the power of 3,000. So I add 1 minus square root of 2. No, or do I subtract? I think I subtract. Do I subtract or add? Hold on. No, I don't subtract. I think I. Hold up. So an to the plus bn. What is this gonna equal? Okay, so what is the 100th digit to the right? I remember this being like, it's just 0.99999. So like, so it's just gonna be 9 because like, there's just so many nines. The question is, how many nines? So, oh, I guess if okay, so if 1 minus square root of 2 to the power of n is less than like 1 over 10 to the power of 100, oh sorry, yeah, to the power of 3,000, then I would have proved my point because, yeah. So that means like 1 minus square root of 2 is like 1 minus 1.41. Sorry. Uh, yeah, I mean, I can just do square root of 2 minus 1 to the power of 3000 because it's even anyways. Yeah, okay, I don't know why I tripped up on that. Square root of 2 minus 1, so that's 0.414, but let me like increase it and let's say even 1/2, right? 1/2 to the power of 30 is definitely less than 1/10. So, uh, yeah, it's definitely going to be 0.999 something, so it's just going to be 9. Remember never really liking that anyway, so like that problem because I don't know, it felt like yeah, that's the yeah, some bullshit. Mm, yeah. Oh yeah, I guess I'd improve that it's always gonna be an integer, but like, hey, bruh, like it's pretty. I think it's if it's even, then I can just do like actually. Hold up. Okay. Well, whatever. Let me just do this one. How many people do we need in a class to make sure that the probability that two people have the same birthday is more than 1/2? Okay. Oh, is more than 1/2. Okay. I guess let it be n. Let's say there's like n people, n whatever. The probability that any two people have the probability that two people in general have the same birthday is like, so there's n ways to select the birthday, right? So the probability that one of them has it is for sure 1. The probability that like at least one more person has it is like 1 minus the probability that none of them have it. So n times 1 minus probability that none of them have it is like the first kid is gonna have like, so I think it's like n times 1 minus, so that guy, the first kid's gonna have to have 364 over 365. The second kid is gonna have to do 363 over 365. Third kid, yeah. So n ways to pick it, and in each of the cases, actually, am I doing this right? Hold on. Should I do number of ways over number of like? Wait, hold on. What's the previous problem? Okay, never mind. I just looked at mailed to the wrong firms. Okay, so that's just like mailing and shit. Okay. But okay, let me see. So the total number of ways I can have at least 2 is 1 minus number of ways all of them have that, right? Yeah. Oh wait, I can just do 1 minus like all the way. Yeah, so like, so yeah, okay, I can do like complementary type. So 360, so let it be n, so I'd say 365 to the power of n minus uh, probability that they all have the same thing is or like, you get what I mean. 365 times 364 times, and it keeps going until 365 minus n, because let's say there's two people, it would be 365 minus n plus 1, I think, right? Minus n plus 1 over all this over total number of cases, which is 365 to the power of n anyways, is at least 1/2. So bro, I don't know. Like 360, so yeah, it's like 365 times. So if that is interesting, so 365, so 1 minus 365, like that product, I'm just going to call it pi over 365 to the power of n is greater than 1/2. So pi over 365 to the power of n is less than 1/2. Okay, so let me actually write this one out. So 365 times 364 times 363 times, and it keeps going, times 365 minus n plus 1, or 366 minus n, over 365 is less than 1/2. Do I get a, I don't know how to do this. Or 365 to the n, sorry. Like what? How the hell am I supposed to do this, bro? Am I supposed to like expand the like, do I do 365 minus 1 times 365 minus 2 times all that? That seems ridiculous though. I don't know, what's the solution? Okay, what? They just don't even do it? Okay, so okay, well that has to be rage bait. I don't know what to say, what to do. Yeah, how the hell did you even arrive at that conclusion? Like, okay, let me ask chat or something. How do you actually solve for n here, because they just said it's 23. There isn't an algebraic way? Okay. Approximation, take logs. No way they want you to do any of this shit. Oh, okay. So yeah, I think it's interesting though. So Holy shit, yeah. This is. Alright, yeah. Okay, well, I think, yeah, I think I'm gonna wrap it up because, actually, you know what? Cubic integer seems like kind of small, at least like a little problem. So let x be an integer between 1 and 10 to the power of 12. What is the probability that the cubic of x, huh? X cubed ends with 11 to the power of 11? 11 to the power of 11 ends with that. So 11, 1. Okay, so it's 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I mean, I think the next one is 1, 5. Never mind. I don't know what the next one is, but like, I only know until 1, 4, 6, 4, 1. That's 11 to the power of 4. What is the probability that. I just need to know how many digits this is, and then I can do like the number of digits like between, like, I'm assuming if this has, let's say, like 10 digits, then like I'll just do like so it can have 10 digits, so that's 1 plus, let's say it has a digit in front of it, there's going to be 1 through 9 times that, so that's 1 plus 9 plus, and then if there's 2 digits in front of it, then it goes from 10 to 99, so that's 90. So 1 plus 9 plus 90, so that's 99, but that's only if it's like 10 digits. So how do I find the digits? I guess 10 plus 1, oh yeah, 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 10 plus 1 to the power of 11, so um, 11 choose, okay, so that is 11 choose 0 times, hold up, wait, 10 plus 1 squared, let's see this, right? So it's 2 choose 0 times 10 squared times 1 to the 0 plus 2 choose 1 times 10 times 1 plus 2 choose 2 times 10, sorry, 1 squared. But okay, the 1 doesn't matter, it's just looking at that. Okay, so 11 choose 0, oh, okay, so okay, but it's to the power of 11, so this is kind of annoying, but 11 choose 0 times 10 to the power of 11 plus 11 choose 1 times 10 to the power of 10 plus 11 choose 2 times. Okay, so this always seems like it's going to be off the order of, so 11 to the power of 11. What is the probability? Okay. So 11 choose 2 is, so let me just make sure that, okay, you know what, let me just do it. Let me just shut up and do it. So 1 plus 1 through 9, so I'm assuming 1 over 10 to the power of 11, hopefully. I don't want to calculate it out. Should be, oh, the cubic of x. Oh shit, okay, I completely misread it. Okay. Yeah, that's why it says cubic of integer. Okay. I thought it was just the probability that any number ends with that. Oh, okay. That changes a lot. Oh, okay, I'm stupid. I guess I'm just gonna see the solution. Okay, well, this is kind of lame, I guess. Okay, so it's, Alright, okay. I mean, I can like barely concentrate. Okay. Yeah, sure. Suppose we have the 3B ends in 1. What is going on? Units digit 1. Why can A not be 9? I'm so confused. 9. Oh, sorry, it's cubed, not squared. I'm stupid. Okay. Yeah. The tenths only depends on 30B. You have a 3B. The 10th digit. Which requires the last digit of B to be 7. Oh shit, I forgot I was still recording. I just zoned out. But yeah, okay, that was the vid, I guess. um, yeah, I'm not editing any of this shit, but yeah. Peace.